Question 3. Is the interconnection of ideal sources in circuit given this figure valid? Explain. Okay, so let's see. So we have to see if there's any contradiction or not. Here 5 amp is going through this circuit, 5 amp. And we have some independent voltage sources, plus volt, 15 volts. So basically, I don't see any contradiction. Contradiction happens if, for example, if you had, I don't know, like a 2 amp is going this way, and let's say 3 amp going that way. So this definitely was a contradiction, because we know that on any node, the amount of the current entering the node must be equal to the amount of the current out in the node, okay? Current in, current out. But here we don't see any contradiction. So this current source can handle any voltage. So there's some amount of voltage across that. And then these voltage sources can also handle any currents. There's no contradiction. So this is a valid. So the first part, this is a valid circuit. Okay, part A. Now part B, I identify which sources are developing power or which sources are absorbing power. Okay, to do that, you have to find the power, each element, and see if the power is positive or negative. So let's do one by one. So let's say this is element 1, this is element 2, and this is element 3. For each of them, I need to know voltage and currents and then find the power. Okay, so voltage here, let's say, I just put the reference voltages. This is plus and minus 20 volt that we know. Let's say this V is 20 volts, V1 20 volts with these references. And then I, as we saw, is 5 amp, right? Okay, 5. So for P1 is V1 times the current that enters the plus terminal, which is happen to be exactly 5 amp. So 20 times 5 is 100. So P1 is 100 watts. It's positive, which means that it consumes power. Now let's look at the element 2. Element 2. Okay, it has 15 volts. Let's say this way is 15. So V2 15 times, okay, this is important. 15, this is positive and this is negative, 15. Then I will look at the I that is in this direction. So 5 amp is going this way. So therefore negative 5 amp is going that way. So therefore I would say 15, which is positive, times negative 5 amp. Very good. Which is negative 75 watts. Very good. Now element 3. This is the current. Let's say I put plus and minus V3 and then the current. Okay, so but what is V3? How much is V3? We have to look at the voltages, like voltage of this point minus that point. Okay, so let's see. This minus that's in 15, but then from here to here, there's an increase in the voltage. Okay, so therefore I would say, let's first do the V3. V3 with the given direction is from this point minus that one, which is 15. But then from here to here, there's gonna be an increase in the voltage, or in other words, you can say I hit the negative here, so it's going to be negative 20. It's going to be minus 5 volts. Yeah, so when we are studying KVL, probably you're gonna see this more. But for now, see, or we can go from this point. So first, there was a 15 volt drop, okay? Sorry, 20 volt drop. So if this is, let's say if this was ground, then this point was negative 20 volts. But then it was a 15 volt increase. So negative 20 plus 15 would be negative 5 volts. Okay, so I would like to think of this in different ways so that you get more familiar with exactly what's going on. Okay, very good. So again, you can either say this is 15 and then because the negative 15 minus 20, or just start from here, assume it's a 0, and then just see how much would be the voltage at this point and just the difference of that, minus 5. Okay, however it works for you. And then P3. P3 is plus minus V3, which is negative 5 volts times the I, which is going to that, which is 5 amps, minus 25 watts. Okay, very good. So we have 3 elements, and then we calculated the wattage for all of them. And now let's see how much is the summation of all these powers. So P1 plus P2 plus P2. So 100 minus 75 minus 25, which is 0. Very good. So it means that we have the power balance. So probably our calculation is correct. So it's a somehow sanity check to see if our circuit worked. We did the math correctly. Total power has to be always 0 in a circuit. And now the elements that have positive power, basically they are absorbing power, like a resistor, lamp, or fan, or something. And the element with negative power, they're generating, delivering power. Okay, hope this is clear.